Hello dear students, in this video I'll continue with revision for term 2 examination. In this video we will see some of the topics from financial mathematics. Financial mathematics of unit 7, the weightage for this unit is 15 marks. And in this video we will see some of the problems from these topics: perpetuity, effective rate, depreciation and compound annual growth rate. Now the questions from these topics we can expect for 2 marks or 3 marks. Now starting with the practice questions. The first one: assuming that Shyam holds a perpetual bond that generates an annual payment of rupees 500 each year. He believes that the borrower is creditworthy and that an 8% interest rate will be suitable for this bond. Calculate present value of this perpetuity. So here we need to find the present value of perpetuity of a bond, perpetual bond which pays rupees 500 as annual payment at the end of each year and interest rate is 8%. So the present value of this perpetuity is given by P is equal to R by I. Here I is 8%, it is 0.08. So P is equal to R is 500 upon I is 0.08. This is nothing but rupees 6,250. Next question: at what rate of interest will the present value of a perpetuity of rupees 800 payable at the end of every 6 months be rupees 20,000? So here we need to find the rate of interest for this amount, rupees 800, and whose present value of this perpetuity is given. The present value of this perpetuity of rupees 800 is rupees 20,000 and it is payable at the end of every 6 months. Let us take, let R be the rate of interest. So we have the rate per period I will be R by 2. So here this is R and this is the present value of perpetuity P. We have P is equal to R by I. So P is given as 20,000 equal to R is 800 upon I is R by 2. From this we get 20,000 is equal to 1,600 upon R, or R is equal to 1,600 divided by 20,000. This is equal to 0.08. Therefore, R is equal to 8%. So the rate of interest is 8%. Next question: the present value of a perpetual income of rupees R at the end of each 6 months is rupees 2,50,000. Find the value of R if money is worth 6% compounded semi-annually. So here we need to find the value of R. The present value of perpetuity is given and it is given money is worth 6% compounded semi-annually. So here P is equal to rupees 2,50,000 and the rate per period I will be 6% divided by 2, or it is 0.03. So the present value of perpetuity P is equal to R by I. P is given as 2,50,000. R we need to find. I is 0.03. So from this we get R is equal to 2,50,000 into 0.03. 2 zeros will go, decimal point will go. So here we get 7,500. Therefore, R is equal to rupees 7,500. Next question: what sum of money is needed to invest now so as to get rupees 10,000 at the beginning of every month if money is worth 5% per annum compounded monthly? So here we need to find the sum of money that has to be invested now so that we will be able to get rupees 10,000 at the beginning of every month. If it is at the beginning, then the formula for present value of perpetuity is P is equal to R plus R by I. Here R is rupees 10,000 and I is the rate per period. It is 5% per annum compounded monthly. So the rate per period will be 5% divided by 12, or it is 0.05 upon 12. Let us keep this as it is. So this is equal to 10,000 plus 10,000 upon 0.05 divided by 12. So it is 10,000 plus, when we simplify, we get 1,20,000 upon 0.05. Now this is nothing but this is 24 lakhs plus 24 lakhs. Therefore, P is equal to 24 lakh plus 10,000. So it will be rupees 24 lakh 10,000. If we invest 24 lakh 10,000 now, where money is worth 5% compounded monthly, we will be able to get rupees 10,000 at the beginning of every month. So far we have seen some of the questions of perpetuity, and now we have questions from effective interest rate. Find the effective rate that is equivalent to a nominal rate of 8% compounded quarterly. So we have R effective is equal to 1 plus R by M the whole raised to M minus 1. This R is the nominal rate. It is given 8%. R is equal to 8%, or it is 0.08. And here it is given 8% compounded quarterly. So M is the number of conversion periods 1 year. In 1 year, if 8% is compounded quarterly, in 1 year there are 4 quarters. So M is equal to 4. Effective rate of interest is equal to 1 plus 0.08 divided by 4. The whole raised to 4 minus 1. So it is 1 plus 0.02 by 0.02 the whole raised to 4 minus 1, or it is 1.02 the whole raised to 4 minus 1. 1.02 the whole raised to 4 is given in the question. So the effective rate of interest will be 1.0824 minus 1. It is 0.0824, or it is equal to 8.24%. Therefore, R effective equal to 8.24%. This is the effective interest rate. Next question. Find the declared rate of return compounded semi-annually, which is equivalent to 6% effective rate of return. So here the effective rate of return is given. We need to find the nominal rate of interest. Here let us take, let R be the nominal rate of interest. It is given, the effective rate of interest is 6%. R effective equal to 6%, or it is equal to 0.06. And then we need to find the declared rate of return compounded semi-annually. So in this case, the number of conversion periods per year, it will be equal to 2. So using the formula, R effective is equal to 1 plus R by M the whole raised to M minus 1. We can find the value of R. This implies R effective is 0.06 equal to 1 plus R by 2 the whole square minus 1. In all these questions that I have discussed, writing the formula is very, very important. Formula alone carries 1 mark and the final answer carries 1 mark. Here 1.06 equal to 1 plus R by 2 the whole square. We can raise both sides to the power half. Here we will have 1.06 the whole raised to half. It is equal to 1 plus R by 2. Or we get 1 plus R by 2 equal to 1.06 the whole raised to half. 1.06 the whole raised to half, it is given as 1.0296 equal to 1.0296. From this we get R by 2 is equal to 1.0296 minus 1, it is 0.0296. So R is equal to 2 times 0.0296, or it is 0.0592. Therefore, R is equal to 5.92%. So this is the declared rate of return or nominal rate of interest. Next question, to what amount will rupees 12,000 accumulate in 12 years if invested at an effective rate of 5%? So we need to find the amount 12% will accumulate in 12 years if it is invested at an effective rate of 5%. So here let us take, let the sum accumulated be A. This is the usual formula that we have studied. Compound interest formula, A is equal to P into 1 plus R by 100 the whole raised to N. Using the same formula, we can find A. Given P is equal to rupees 12,000, N is equal to 12 and R is equal to 5%. We have taken, let the sum accumulated be rupees A. So A is equal to P into 1 plus R by 100 the whole raised to N, or it is 12,000 into 1 plus 0.05 the whole raised to 12. This is 12,000 into 1.05 the whole raised to 12. They have given it as 1.7958 into 1.7958. This when we multiply, we get it as 21,549.6. So the sum accumulated is 21,549.6. Next we have the next type of questions where we have to compare two different yields. Which gives better yields? 8.4% per annum compounded monthly, 8.5% per annum compounded semi-annually. So let us take two cases. When 8.4% is compounded monthly, we have R is equal to 8.4% and the number of conversion periods per year. It is here it is compounded monthly. We have 12 months in a year. So M is 12. This is 0.084. R effective is equal to 1 plus R by M the whole raised to M minus 1. So it is 1 plus 0.084 upon 12 the whole raised to 12 minus 1. This is nothing but 1 plus 0.007 the whole raised to 12 minus 1. This is 1.007 the whole raised to 12. It is 1.0873. So this is 1.0873 minus 1, which is 0.0873. Therefore, in this case, the effective rate of interest is 8.73%. We can find which gives better yield by comparing the effective rate of interest. The one which has higher effective rate of interest will give better yield. Next, we have when 8.5% is compounded semi-annually, we have R is equal to 8.5% or it is 0.085 and M is equal to, here it is compounded semi-annually, so M is 2. In this case, the effective rate of interest will be 1 plus 0.085 upon 2 the whole square minus 1. It is 1 plus 0.0425 the whole square minus 1. This 1.0425 the whole square is given as 1.0868. This is 1.0868 minus 1 or it is 0.0868. Therefore, the effective rate of interest in this case, it is 8.68%. When we compare these two, this is more. This value is more. Therefore, 8.4% compounded monthly is more effective or it gives more yield. Gives better yield. Next question. Mr. Y has two investment options, either a 10% per annum compounded semi-annually or 9% per annum compounded continuously. Which option is preferable and why? So when 10% per annum is compounded semi-annually, we have R is equal to 10% 0.1. It is compounded semi-annually, so M is 2. Effective rate of interest is given by the formula 1 plus R by M the whole raised to M minus 1. It is 1 plus 0.1 by 2 the whole square minus 1. It is 1 plus 0.05 the whole square minus 1, or it is 1.05 the whole square minus 1. 1.05 the whole square is 1.1025 minus 1. This is 0.1025. Therefore, R effective in this case, it is 10.25%. Next, we have when 9.5% is compounded continuously. In this case, we have R is equal to 9.5%, or it is 0.095. When interest is compounded continuously, we have effective rate of interest as e raised to R minus 1. It is e raised to 0.095 minus 1. E raised to 0.095 is 1.0996. This is 1.0996 minus 1, which is 0.0996. This is 9.96%. So when we compare the effective interest rate of these two, this is better. Investing at 10% per annum is better. Next question. A moneylender charges interest at the rate of rupees 10 per rupees 100 per half year, payable in advance. What is the effective rate of interest does he charge per annum? The interest is rupees 10 for rupees 90 per half year for 6 months. Therefore, interest per 6 months this is equal to 10 by 90, or it is equal to 1 by 9. Interest per period I, it is equal to R by M, it is equal to 1 by 9. So the effective rate of interest that is charged per annum, it is calculated as R effective is equal to 1 plus R by M the whole raised to M minus 1, or it is 1 plus I the whole raised to M minus 1. Interest per period is 1 by 9. So the number of periods is M is equal to 2. So here we have 1 plus 1 by 9 the whole square minus 1. So this, when we take LCM and simplify, we get 100 by 81 minus 1, or it is equal to 1.2345 minus 1. It is 0.2345. Therefore, the effective rate of interest per annum, it is 23.45%. So this is the effective rate of interest. So far we have seen problems on effective rate of interest. Next we have compound annual growth rate. An investment made by Mr. Roy has initial value rupees 10,000 and it increases to rupees 40,000 in 3 years. What will be compound annual growth rate? So here the initial value is 10,000 and the ending value is 40,000, and the number of investment periods or the time for which this investment is made is 3 years. We need to find the compound annual growth rate. The compound annual growth rate is given by the formula ending value upon starting value, the whole raised to 1 by n minus 1 into 100. So this is the compound annual growth rate formula, where EV is the investment's ending value and SV is the investment's starting value. N is the number of investment periods. So here we have ending value is 40,000, ending value is 40,000, starting value is 10,000 and number of investment periods is 3. Using this we can find the compound annual growth rate. It is given by 40,000 upon 10,000, the whole raised to 1 by 3 minus 1 into 100. So this is 4 raised to 1 by 3 minus 1 into 100. 4 raised to 1 by 3 is given as 1.587 minus 1 into 100. This is 0.587 into 100, or the compound annual growth rate is 58.7%. It is always expressed in percentage, so the compound annual growth rate is 58.7%. Next question, Mr. Abhishek has invested rupees 1 lakh in a financial plan whose compound annual growth rate is 9.5% and he received a final value of rupees 2,50,000. Find the period completed for which he has invested the amount. So here the ending value is given, starting value is given and the compound annual growth rate is given. We need to find the period for which it is invested. We need to find N. First let us write the formula. Formula carries 1 mark. It is ending value upon starting value, the whole raised to 1 by n minus 1 into 100. Given ending value is rupees 2,50,000, starting value is rupees 1 lakh. We need to find N. Compound annual growth rate is 9.5%. Similar question was asked in the sample paper for 3 marks. So this implies 9.5% or 9.5 equal to 2,50,000 upon 1 lakh minus 1, this whole raised to 1 by n minus 1 into 100, or 0.095 equal to this. When we simplify we get 2.5. 2.5 the whole raised to 1 by n minus 1, or we get 1.095 equal to 2.5 the whole raised to 1 by n. If we take log on both sides, we get log 1.095 equal to 1 by n log 2.5. 1.095 is given here. From this we can write n is equal to log 2.5 upon log 1.095. The log values are given in the question. Let us substitute here. This is 0.3979 upon 0.0394. This, when we simplify, we get it as approximately equal to 10. Therefore, n is equal to 10 years. In this question, writing the formula carries 1 mark. Then substituting the values and up to this step carries 1 mark. Remaining steps and the final answer carries 1 mark. Next question, calculate compound annual growth rate from the following data. So for year and revenue, the corresponding data is given here. For various years, the corresponding revenue is given. We need to find the compound annual growth rate. Here it is given for 2015 it is 3 lakhs, 2016 3,50,000, 2017 4 lakhs and 2018 4,50,000. Here we can easily see that the starting value is 3 lakhs and the ending value is 4,50,000. This 3 lakhs, it is the revenue at the end of 2015. So this is the revenue at the beginning of 2016. This is the beginning of 2016. The revenue is 3 lakhs. And at the end of 2018, it is 4,50,000. So the number of investment periods, it will be 3 years, 2016, 2017 and 2018 in this case. Compound annual growth rate is ending value upon starting value, the whole raised to 1 by n minus 1 into 100. So here ending value is 4,50,000. Starting value is 3 lakhs. And n is equal to 3. From this we can find the compound annual growth rate. 4,50,000 upon 3 lakh, the whole raised to 1 by 3 minus 1 into 100, or it is equal to this. When we simplify, we get it as 1.5. 1.5 the whole raised to 1 by 3 minus 1 into 100. Value is given in the question. 1.5 the whole raised to 1 by 3 is 1.1447 minus 1 into 100. This is 0.1447 into 100, or it is 14.47%. So the compound annual growth rate is 14.47%. Next question, Mr. Kumar has invested rupees 20,000 in the year 2014 for 5 years. If compound annual growth rate turned out to be 11.84%, what will be the end balance? Here again compound annual growth rate is given and the starting value is given. We need to find the ending value. We have compound annual growth rate equal to ending value upon starting value, the whole raised to 1 by n minus 1 into 100. Compound annual growth rate is given as 11.84%. Then starting value is rupees 20,000 and n is 5 years. This implies 11.84 equal to ending value upon 20,000, the whole raised to 1 by 5 minus 1 into 100. If we divide both sides by 100, here we will get 0.1184 equal to ending value upon 20,000 whole raised to 1 by 5 minus 1, or it is 1.1184, which is equal to ending value upon 20,000 the whole raised to 1 by 5. We can raise both sides to the power 5. So here we will get 1.1184 the whole raised to 5 equal to this 5 and this 5 will go, ending value upon 20,000, or ending value equal to 20,000 into 1.1184 the whole raised to 5. This 1.1184 the whole raised to 5, it is given as 1.7498. So this is 20,000 into 1.7498. This, when we simplify, we get 34,996, or it is approximately equal to rupees 35,000. So this is the ending value of investment. Next question, Mr. Ahmed invested rupees 10,000 in a company's fund. His yearly investment values are shown in the table below. From year 0, 1, 2, 3, the amount is given. We need to find the compound annual growth rate. So here for year 0, amount is 10,000 means at the beginning of year 1, the value is 10,000. So the investment starting value is 10,000 and the ending value is 22,056. We can find a compound annual growth rate as ending value upon starting value, the whole raised to 1 by n minus 1 into 100. Here the number of periods is 3. So this is 3. It is 22,056 upon 10,000 minus whole raised to 1 by 3 minus 1 into 100. It is 2.2056, the whole raised to 1 by 3 minus 1 into 100. This value is given here, it is 1.3016. This, when we simplify, we get 0.3016 into 100, or the compound annual growth rate is 30.16%. So far we have seen questions on compound annual growth rate. Now we will start with depreciation. On 1st April 2021, Rekha purchased an LED TV costing rupees 50,000, spent 5,000 on its erection. The estimated life is 5 years with a scrap value of 3,000. Calculate the depreciation using linear method with accounting year ending 31st March 2022. So depreciation is very easy. Annual depreciation using linear method, the formula is C minus S by N, where C represents cost plus erection charges, S is the scrap value minus scrap value, upon N is the expected useful life. So here cost is 50,000, erection charges 5,000, salvage value 3,000, and expected life is 5 years. So this is 52,000 by 5, or it is 10,400. Therefore annual depreciation D equal to rupees 10,400. Next question, an asset costing rupees 96,000 is expected to have a useful life of 6 years, has final annual depreciation of rupees 6,000. Find the final scrap value of the asset. So here the cost is given, useful life is given, and the depreciation is given. We need to find the scrap value. Let us take, let S be the scrap value. Annual depreciation D is given by C minus S upon N. Depreciation is given as 6,000 equal to C is 96,000 minus S upon N is 6 years. So from this we get 36,000 equal to 96,000 minus S, or S is 96,000 minus 36,000, which is 60,000. So this is the scrap value of the asset. Next question, a piece of machinery costing rupees 1 lakh is expected to have a useful life of 5 years and scrap value rupees 20,000. Using straight line method, find the annual depreciation and construct a schedule for depreciation. Also find the depreciation rate percent. So here first we have to find the depreciation, that is very easy, and then we have to construct a depreciation schedule. So annual depreciation is given by C minus S upon N. C is 1 lakh, S is 20,000, upon N is 5. So this is 80,000 by 5, which is rupees 16,000. This is the annual depreciation D. To construct a depreciation schedule, let us draw a table like this with year, annual depreciation, accumulated depreciation, and book value of the asset. Year 0 means it is at the beginning, annual depreciation is 0, accumulated depreciation will also be 0. At the end of year 1, we have to add these two. It is 16,000 plus 0, 16,000. Then at the end of year 2, the accumulated depreciation will be 16,000 plus the next year's depreciation. It is 32,000. At the end of year 3, accumulated depreciation will be 32,000 plus annual depreciation 16,000. 48,000. At the end of the 4th year, annual depreciation will be 48,000 plus the depreciation for the 4th year 16,000. It is 64,000. And for the 5th year, it will be the sum of these two, which is 80,000. So at the end of 5th year, we should get accumulated depreciation as this C minus S value, 80,000. Now, the book value of the asset at the beginning, it is rupees 1 lakh. All these are in rupees. After 1 year, the book value of the asset will be book value at the beginning minus depreciation. So 1 lakh minus 16,000. It is 84,000. And then book value at the end of 2nd year, it is the original cost minus the depreciation. So it is 1 lakh minus 32,000 minus 32,000. It is 68,000. And then at the end of 3rd year, it is 1 lakh minus 48,000. 52,000. At the end of 4th year, it is 1 lakh minus 64,000, which is 36,000. And at the end of 5th year, it is 1 lakh minus 80,000, which is 20,000. So at the end of the life of the asset, the book value was the scrap value. These two are equal. So this is the depreciation schedule. Next, we have to find the depreciation rate percent. The depreciation rate percent, it is calculated as D upon C minus S into 100. It is 16,000 upon 80,000 into 100. So this is equal to 20%. This is the depreciation rate. Next question, find the present value of annuity of rupees 1,900 payable at the end of each year for 3 years if money is worth 5.6% compounded annually. So this is present value of annuity of rupees 1,900 where money is worth 5.6% compounded annually. So here it is given R is equal to rupees 1,900, N is equal to 3 years and I is equal to 5.6% or it is 0.056. So the present value of ordinary annuity, it is given by R into 1 minus 1 plus I the whole raised to minus N upon I. It is 1,900 into 1 minus 1 plus 0.056 the whole raised to minus 3 upon 0.056. 1,900 upon 0.056 comes out to be 33,928.59 into 1 minus 1.056 the whole raised to minus 3 is given as 0.8492. So this is 33,928.59 into 0.1508. This when we simplify, get it as 5,116.43. Therefore, the present value of annuity of rupees 1900 payable at the end of each year for 3 years when money is worth 5% compounded annually. It is rupees 5116.43. I hope this video was useful for you. Thank you for watching.